Okay, so in 10.7 we're using the discriminant to find the number of real solutions. The book shows this actually after you learn about the quadratic formula. I'm going to show you the quadratic formula. It is negative b plus or minus the square root of b squared minus 4ac all over 2a. The quadratic formula is a way to find the real solutions and down the road imaginary solutions, but we're going to focus on the real. We can find the real solutions to any quadratic equation, but we're going to focus first on the discriminant, which is actually what appears inside of the radical. So before we look at using the formula to find the solutions, it would make sense to determine if there are any solutions, because some quadratics have 2, some have 1, and some have no solution. So that radical is going to determine how many solutions there will be. So let's look at some examples. If we have something inside the radical that looks like this, negative 6 squared minus 4 times 1 times 3. So that would be our B, our A, and our C. If we simplify this, then we have 36. 4 times 1 is 4, times 3 is 12, so that would be minus 12. And we're going to get a positive 24 inside the square root. Well, as long as we have a positive number inside of the square root, then there will be 2 solutions, because it'd be the positive and negative of the square root of 24. If we have a situation inside the square root, which is negative 6 squared minus 4 times 1 times 9, and we simplify that, we have 36. 4 times 1 is 4, times 9 is 36, so that would be minus 36. We get the square root of 0. So the square root of 0 is just 0, which means we only have 1 solution. The third possibility inside the square root is if we have negative 6 squared minus 4 times 1 times 12, we have 36. 4 times 1 is 4, times 12 is 48, so we're subtracting 48. So inside the square root, we would get negative 12. When you have a negative inside the square root, there's no solution because there is no number times itself that is going to give us a negative product. So in this case, there would be no solution. So what we can focus on is if the discriminant b squared minus 4ac results in a positive number, there should be 2 solutions. If it results in 0 as a result, then there would be 1 solution. And if we get a negative inside the radical from b squared minus 4ac, then there would be no solution. You can use this in the radical or not, but we're going to practice a couple problems finding just how many solutions there should be. So the first example, we're going to use 3x squared minus 5x minus 1 equals 0. Recall from previous lessons that 3 is A, negative 5 is B, and negative 1 is C. So if we are plugging into the discriminant, which is inside the radical, it would look like this. it would be negative 5 squared minus 4 times 3 times negative 1. When you square a negative number, this result should always be positive. What follows, I would recommend looking at the product of 4 and 3 and 1 before you worry about the sign. 4 times 3 is 12, times 1 is 12. And within these three numbers, there are two negatives, so we should get a positive. That means inside the radical, we have 37, so we should end up with two solutions. Looking at another example, we find that all of our terms are not always on the correct side. So the first thing you need to do is get everything on the same side equal to 0. So we're going to subtract 2x and add 3 to both sides. So we have x squared minus 2x plus 3 equals 0. We do not plug into the quadratic formula or the discriminant until everything is equal to 0. So if you must, you can put in a 1 if there's nothing in front of your variable. So a would be 1, b would be negative 2, and c would be 3. So using the discriminant, b squared minus 4ac, we have negative 2 squared minus 4 times 1 times 3. Remember, squaring a number always results in a positive number, so this would be 4 minus 4 times 1 times 3. So between these, we should have 12, and there's one negative, so we are subtracting. So in our radical, we have negative 8. This means there should be no solution. We're going to check one more in the way of an example. So we have 5x squared plus 8 equals 2x. So we're looking at getting everything on the same side in standard form. So if we subtract 2x from each side, there is no x term. We're going to have to split these two apart. So we subtract 2x here and here to get 5x squared minus 2x plus 8 equals 0. So this is our A, this is our B, and this is our C, once they're in the proper order. We're going to plug into b squared minus 4ac. So that would give us negative 2 squared minus 4 times 5 times 8. So we have positive 4. 4 times 5 is 20, times 8 is 160. We have one negative in that group, so that's minus. So we have negative 156. Again, since there is a negative number, we would end up with no solution. The reason it's beneficial to look at the discriminant first is if you calculate what's in the square root from the formula, and let's look back at the formula. If we calculate what's in the square root and we find out that we have a negative number, there's no reason to finish the rest of the calculation. We would stop at that point and say there's no solution. If we calculate what's in the square root and we get 0, there is only one solution, which would actually be negative b over 2a. And then, of course, if there are two solutions, we're going to deal with that when we do the entire quadratic formula.